Today we're going to be covering, I call it section 1.04, it's functions and continuity. Now, if you actually look in the book that we have, it's section 1.1. It's the very first one. But I wanted to cover a few other things before we got jumped into this lesson. So let's go through, like I said, lots of vocabulary today. The first vocabulary that we have is a relation. And a relation basically describes the relationship between input and output values. So when I give you a number, how do we get a number out, right? What's the relationship between the two numbers? But we want to talk about specific relations. So we're going to jump here to the next one, which is a function. And a function is a relation where each element of the domain is paired with exactly one element of the range. So I'm going to write in here domain. I can do this. And range. You can check the graph. You can check if the graph is a relation by using the vertical line test. We don't need the extra the that we have here, so toss that out. Well, like it doesn't read right. So we'll talk about the vertical line test. Do you guys remember the vertical line test is if you're given a graph, right? You can pass vertical line and keep moving it from one direction, right, from the left to the right, and it only crosses at one location, then it's a function. Do you remember that? Okay, I'm going to get rid of that. Okay, so let's move on. The domain is the set of x values that you can put into a relation. Up above, we were calling it the input. They introduced codomain, and it's mostly just to introduce you to the word. It's used more in advanced mathematics. The codomain is the set of y values that could possibly result from the evaluation of a function. The important thing to keep in mind here is this: unless otherwise stated, the codomain of a function is the set of real numbers. So a lot of times they'll either tell you what the codomain is in today's lesson, or they won't. And if they don't, then you're going to say that it's the set of real numbers. And as we go through today, I'll make sure I highlight that. The range is the set of y values that actually, see here, actually, as opposed to possibly, right? Because the codomain and the range, we have this contrast here, right? That actually results from evaluating the function. So you guys are used to domain and range. And then up above, we were using the word output. So the range is a subset of the codomain. Subset just means that the numbers of the range are found in the codomain. The codomain is usually larger, okay, and then a subset of those numbers would be the range, but sometimes the range and the codomain can be exactly the same. A word that you probably haven't heard a lot, or a phrase really, is a one-to-one. A function is one-to-one if each element of the range is paired with exactly one element of the domain. Does this definition sound familiar? Wasn't that up there if we look at the definition of a function way up here, right? Notice I just flip-flopped range and domain, and that became the onto definition. So if we want to check if something's a function, we use the vertical line test, right? If we want to check if it's one-to-one, we'll be using the horizontal line test, but we'll come down to that. Okay, a function is onto if the function's codomain is the same as its range. The horizontal line test, place a pencil flat at the top of a graph and move it down to represent a horizontal line. So this time, right, if we have a graph like this, right, we would start moving a horizontal line down, right, and seeing how many times it crosses. If there are places where the pencil intersects the graph at more than one point, then more than one element of the domain is paired with each element of the range. The function is not one-to-one. So if it only crosses at one point, at no more than one point, then it's one-to-one. If there are places where the pencil does not intersect the graph at all, then there are real numbers that are not paired with an element of the domain, so the function is not onto. So let's start applying these just so that you guys can see. So we'll come down here, example 1. Identify the domain, the range, and codomain of the graph. Domain. So remember, domain are the x values that you can get, right? So you're going to be looking at the x-axis. Do you see that? And you're going to be looking to see, do you have points either above or below? Okay. When I make graphs, it's hard to put arrowheads on. So let's put arrowheads on this graph down here and here. Okay, because we know that this graph, right, is going to go down forever this way and keep going that way. And the same thing as we go to the right, it's going to be going down to the right forever. So if we're looking at the domain and we're looking at the x-axis here, okay, whoops, I lost my x-axis that I drew in. Okay, so there's my x-axis. Then you can start looking, and you can see, right? If I go down here, there's a point. If I go down here, there's a point. If I go down here, there's going to be a point, right? Is there a place as I go to the left where it won't be? Going to the left. Is there a place where the graph I won't find a point on the parabola? Okay, I hear yes. Okay, and the answer is no, because the graph is going to keep going down and to the left. I'm kind of accentuating it. So it's just going to be really, really, really far down. And the same thing, if we come back here, notice that on the right, I could keep going down and I find more points. And as I go further and further and further away, I just go further and further down. So the domain for this, isn't it? There are no restrictions. Let's just say that first. There is no restrictions. And so the domain is all real numbers. Okay. Or what we could say is that the x values are going to go from negative infinity to infinity, right? They're never included in set notation. Range. So what's the range for this function? Notice range, we're going to be looking at the y-axis. Do you see that? So are all y values labeled here? Well, notice here I can go left and right here, and I find values left and right here, left and right here, right? I could go down forever, can't I? Because of those arrowheads. Can I go up forever? What about up here? Is there points to the left or to the right? There's not. And so what's the highest the highest value that y can be, right? What's the highest I can go on the y-axis? It's 0. Good job. So because the maximum value of y is 0, and there is no minimum value, meaning do you see that we go down forever, and there's always a value either to the left or to the right? Then the range will be y is less than or equal to 0, or we could say that it goes from negative infinity to 0. We use the bracket to say that it includes 0. Okay, then codomain, and again, they're just trying to introduce you to the topic, start getting used to the definition. It didn't state anything about the codomain, okay? Because it didn't state anything about the codomain, if you remember up here when we were talking about codomain, right? It's the set of possible y values that could result, and it says here, right? Unless otherwise stated, the codomain of the function is the set of real numbers. So we know that it's going to just be the set of real numbers. Because it's not stated in the problem, right? Or we would say from negative infinity to positive infinity. Okay, is the function one-to-one? Well, if I want to see if it's one-to-one, do the horizontal line test. Can you draw a horizontal line such that it crosses at more than 1 point? So here's my horizontal line, no points, crosses at 1 point, crosses at 2 points. If it crosses at 2 points, it cannot be one-to-one. So I'll say here, is the function one-to-one? The answer is no. Okay, why? Because it fails the horizontal line test. Is the function onto? Uh-oh. Well, the onto, if you remember up here, right? The function is onto, I'm looking at this right here, onto if the function's codomain is the same as the range. So we're going to compare the codomain and the range. So you're looking at these here. Are these the same? Is negative infinity to 0 the same as negative infinity to positive infinity? So the answer is no, right? So it's not onto. So I'll write here no. Okay, the codomain and the range are not the same. Okay, I'll give you a second to copy that down. We're going to move on to example 2 on the back. Can I move on? Let's move down here. Example 2. The table shows the values, the number of medals the United States won at 5 Summer Olympic Games. Analyze the functions that give the number of gold and silver medals won in a particular year. Define the domain and range of each function and state whether it is one-to-one, onto, both, or neither. So we'll go through and we'll do it together. So you can see here we have this information. Now, for gold medals, right, let's look at gold medals, then we'll look at silver medals. We'll look at them separately. So gold medals, we are looking at this data right here, and we're using the years right here. Does that make sense? So, and then when we go to do silver medals, we'll use the same years, but we'll use this column. Clear? So let's take a look. It says, let f of x be the function, right here now. Let f of x be the function that gives the number of gold medals won in a particular year. So, there we are. So then it says state the domain. Well, the domain is just a specific number of values. Let me see if I can come in here. I'm going to have to kind of write small. And it starts with 2000, which is at the bottom. And then 2004. 2008. I'll go to the next line. 2012, and then 2016. Now the range are the values that you get out. And so you can see there's a 36 is the smallest. There's a 36 again, but you don't repeat. Then the next highest is the 37. Then there's the 46, and the 46 repeats. So the range is actually only these 3 values. The domain is the 5. Zoom out here a little bit. It says the function is or is not one-to-one because 46 in the range is paired with exactly 2 values in the domain. Okay, now hang on a second. If we're looking for one-to-one, if you remember correctly, one-to-one up here, it says that every element of the range is paired with exactly 1 element of the domain. So let's come back down here, okay, and go through the range. Is 46 paired with exactly 1 number in the domain? No, because 46 is actually also paired with 2016 and 2012. So it's actually paired with more than 1. So then we would say down here, right, so the function is or is not. Well, it's not is. Okay, it will be is not one-to-one because 46 in the range is paired with 2 values in the domain, 2016 and 2012. You see that up here? The 46 counts as 1 number. It's paired here and there, 2016, 2012. But there's also another number that does that. The other number is 36. Do you see it here? It's also paired with 2008 and 2004. So there's actually 2 values. So, and 36 in the range is paired with 2 values in the domain 2008 and 2004. Then we have to decide if it's onto Okay. We have to just say if it's onto. If it's onto, remember, back up here, right? The function is onto if the domain and range are the same, right? Well, here's the thing. Do they tell you what the domain is? No. So what do we assume the domain is? I'm sorry, the codomain. Sorry. They don't tell you the codomain. So what do you assume the codomain is? When they don't tell you, they actually said, assume that it's the set of real numbers. I actually think on this one that it's the set of integers because you can't have half a metal, right? But I think that that's going to be too, I think you guys can understand that. I'm not going to test you if you can figure out if it's between the set of real numbers and the set of integers. Okay. So basically it could be the set of integers. And that, well, and then at that it could be whole numbers. So, but is every whole number then represented? Well, no, only 46, 36, and 37. So it's not onto. Let's do this actually. Because the range does not match the codomain. So we're going to repeat this now with the silver metals. So does the domain change at all for the silver metals, which is the year? No, it'll be the same as the gold metals, but here are the silver metals. So let me go here. So it's going to be, again, 2000, going from least to greatest, 2004, 2008, 2012, 2016. And this time the range, there are no duplicates. So if I go from least to greatest, isn't the smallest 24? Then 29, 37, 38, and 39. This time is the function 1 to 1, right? Well, remember again, right, if I go back up here, if it's 1 to 1, it means each element of the range is paired with exactly one element of the domain. So we could just ask the question, right? Is 37 paired with exactly one number? Yes. 29? Yes. 38? Yes. 39? Yes. And 24. There's no duplicates. They're all paired. So this time it is, right, paired with exactly one. Because no two values in the domain share a value in the range. So, and again, the codomain, you can assume that it's going to be the set of real numbers, but it's really the set of whole numbers because you can't have a partial and you can't have negative metals, right? So, but we'll just say here it's not onto because the range does not match the codomain. Okay. Continuous function, definition. A graph has no breaks, so it's one piece, or discontinuity. Right, and this is holes in the graph, discontinuity. So like if I were to draw a graph that looks something like this, and then there's a hole, right, that is not a continuous function, right? Or if it goes like this, and then picks up over here, right, not continuous, okay? There's discontinuity in this first one here, and there's breaks in the second one. A discrete function is a graph that's made up of points that are not connected. So it might look something like this. Okay. So it says here, look back at the previous two examples and state whether they are continuous, discrete, or neither. So if we look back at example 1, this is example 1. Okay. Are there any breaks or discontinuity in this graph? So do you see any holes? Do you see it? Is it one piece or two pieces? No, it's just one piece, right? Okay. And are all the points connected? Okay, so this is going to be a continuous graph then. And then example 2, when you look at the data, if I were to graph that, would this be a nice continuous curve? Right, here's 2000, right? Here, is it going to look something like this if I graph it? Sorry, let me, oh, here, let's just do this. So if I graph it, it's going to look something like this, where these are the years, like 2000, right? 2004, and then this is going to be the number of metals, right? I'm not trying to graph it perfectly, but isn't it kind of go up and down? Is it connected? No, it's just going to be points, right? So it's not continuous. It's made up of points, and so the second graph is discrete. Okay. Let's go to the last two examples that we have here. Okay, example 4, example 5. Write the domain and range of each function in set builder and interval notation. Determine whether each function is one-to-one, onto, both, or neither. Then state whether it's discrete, continuous, or neither discrete nor continuous. Okay, so on this first one, I'm going to put here, I'm just going to add the arrowheads in just so that you can see them. It makes it like nice and just really hard to come up with graphs with arrowheads. Okay. What's the domain for this graph in example 4? Remember, with the domain, we're going to only look at the x-axis, right? And we're going to look to see, okay, as we go left, is there always a value either above or below? So as I go left here, is it going to continue to find points? Yeah, It's just going to keep getting lower and lower. And as I go right, is it going to be the same? Are there any points that are not defined on this graph on the x-axis? What was that? On the other side? There's no negatives, right? There's no positive. I mean, all the negative, all the positive. But what about what's going on here at 0? There's a break. So this is not going to be continuous, right? We know that. So right away, since you said there's a break, I can cross out continuous down here. So might as well do that as we keep moving. Oh, is this a discrete graph? Like, is it made up of just points that aren't connected? It's not discrete either, is it? So then we know it's neither. We can just tell that by looking. Okay, but we're still trying to answer the question. We see a break here. So can 0 be a part of the answer? Is there an x value at 0? I mean, a y value when x is 0? No, there's a hole there, right? So notice here. Okay, so for the domain, okay, we're going to say the x values are going to be such that, that's what that vertical line means, x can be less than 0, or x can be greater than 0. But notice that I don't include 0, right? Put an equals in there because there's a hole at x equals 0. Are we okay with that? Okay, so that would be set builder notation. If I want to describe this in interval notation, I would say, well, x's can go as low as negative infinity and up to 0, but not including the 0. Infinities are never included. And then we use this union symbol, right, a U, and then we would say, but it can also be numbers that start at 0 but don't include 0, so I'll use the parentheses here, and go all the way up to positive infinity. What about the range? How high and how low does the range go? Well, it looks like it goes up forever, right? And it looks like it goes down forever. Are there any values of y that cannot be in the answer? Yeah, it's right here when y is 0, right? So y can't be 0. So the y values, if I use set builder, will be the y values such that y can be less than 0, or y can be greater than 0, but it just can't be equal to 0, right? So as long as I don't put the equal in there, then that's fine. So the y values can go from negative infinity to 0, but not including 0. Union that with, and they can go from 0, but not including it, all the way up to positive infinity. Okay, did they tell us what the codomain is? Did they tell you what the codomain is? Nope, right? And so here, we would say that it's a set of real numbers. We use that hashtag symbol for numbers. Or we could say that it's from negative infinity to infinity. I noticed that in the book, they're going to use this notation too. They might say something like y is an element, and then of the set of real numbers. It's just like mathematical notation. That is an element this is of the set of real numbers. Okay, so we already did discrete, continuous versus neither. So now we got to figure out, is it one-to-one onto both or neither? Okay, so one-to-one, we can do the vertical line, the horizontal line test. Does it pass the horizontal line test? Does it ever cross at more than 1 point when we pass a vertical line? If it crosses at more than 1 point, it fails, right? Does it ever fail? No. So it is one-to-one. How can I check if it's onto? Look at the range and the codomain. Okay. Do these match? Oh. These do not match, right? So therefore, right, it's not onto. So it's not onto, so it can't be both, and it can't be neither. So we know that it can't be both, or we know it's one-to-one though, because we already said that it passed the horizontal line test, right? Yeah. Passes horizontal line test. Are we okay with that? I'll tell you right now, if I'm going to test something that has to do with codomain, which is really onto on the test, I'll give you an actual picture of a graph. I won't give you the discrete data like I did in example 3. Okay? 2, example 2, sorry. I don't want to, I think that would be too confusing. Could I move on to the last example? Okay. For this one, let's put our arrowheads on. Well, the first thing, it's probably the easiest thing is just decide, is it discrete, continuous, or neither? So is it discrete so that it's made up of a bunch of points that aren't connected? Nope, not discrete. Is it continuous? Does it ever break, come in more than one part? Nope, so it's continuous, isn't it? So it can't be neither, so I can cross that out. Let's work on domain. Okay, so the domain for this one, is there a value as I go left or as I go right on the x-axis where there's not a y value paired with it? One y value? Right, there's a value here, there's a value here, there's a value here, there's a value up here. So isn't the domain, is there any place where the graph breaks where there's no domain represented? Not in this one, right? So it's the values of x such that we go from negative infinity, right, where to positive infinity. So we could write it like this, right, where x is greater than negative infinity but less than infinity. We might say x such that x is an element of the set of real numbers. Okay, and then in interval notation, we say negative infinity to positive infinity. How about the y values? Is every y value represented as we go up here? Yeah, we can find places left and right, of that. How about as we go down? Is there every y value represented in the negatives? Okay, I see some people shaking their head no. Why no? What's the smallest the y can be? Yeah, it can only go down to, isn't this it right here? Do you see it? -4. So the smallest, so the range in set builder notation will be the values of y such that y has to be greater than or equal to a -4. Okay, and if I write that in interval notation, the smallest is -4, the biggest is positive infinity. Infinity is never included. The -4 is, so you use a bracket. Yes? What do you mean all of these are equal to the same thing? Mm-hmm. Oh, yeah. These are all the same way of communicating the same idea. No, but I want you to be familiar with them. I noticed that the answers in the back of the book for interval notation write it this way. Not interval notation, set builder notation, sorry. Are we good with that? What's the codomain? Well, the codomain, they didn't tell us, right? So then we get to say that it is the set of real numbers. So we could say the y values are an element of the set of real numbers, or we could say it goes from -infinity to positive infinity, right? All those are different ways of communicating that. Well, okay, that allows us to figure out onto. Onto, these have to match, right? This one and this one have to match. Do these match? Okay, these don't match. So therefore, when I put dots in a triangle like that, it means therefore, um, this is not onto. So I get to cross out onto here, which means I get to cross out both because it can't be both. Okay. And then the last thing I need to do is figure out, is it 1 to 1? So as I pass horizontal lines, does it cross at more than one point? Yeah, it does. So is it onto? Nope. So we get to, it's not on, or sorry, it's not 1 to 1. Sorry. It's not 1 to 1. So, so we can cross out 1 to 1, which means that it will be neither. And that will wrap up the lesson.